All right, go ahead and kick it off. Thank you so much, everyone, for joining today. It's really good to see all of you. This is recorded, so we will be sharing the recording after the demo. Um, this is an energy-focused, energy applications-focused demo, as you might have seen in our marketing on our website. So really excited to share a few different use cases with you for the CubeNexus Decision Intelligence Suite. It will be about a 30-minute demo. I'll be showing these scenarios for the first 15 to 20 minutes or so, and then we'll just leave it open for Q&A after that. The Zoom call is 45 minutes long, so if we do need to run over for additional questions, not a problem, but we'll aim to have it wrapped up by about the bottom of the hour. So that said, I will kick it off. These are the three scenarios that we're going to be going over today. So as some of you might be aware, if you've looked at some of our material, what CubeNexus really does is it integrates and structures data. So we are able to take any type of information from any type of sensor and synchronize that in multiple dimensions in a 3D cube-based spatial reference framework, instantly making that data interactive for querying, visualization, and other AI applications. So the three different scenarios that we wanted to go over today are a grid operation scenario. We've had some interesting and promising leads among companies that do grid operations, so we wanted to cover that. And then, as you know, we're based out of Tulsa. I'm up in Chicago, actually, but we have quite a bit of interest in the energy space in the oil and gas sector. So wanted to give a midstream example from pipeline management company and then an offshore example as well, the type of queries, insights, and visualizations that we could see if we had the data structured into the CubeNexus system and users in those companies were using the Decision Intelligence Suite. So I will stop sharing for just one moment as I flip over to the website and demo, because I know that is what everyone is really here to see, not to see slides. And again, feel free to put in any questions or thoughts in the Q&A. As I am talking, I will get to all of them at the end. And yes, Christina, I will share the recording after the event. Anyone who registered will get the recording, and then we will also post it on to YouTube and on our website. All right, so when you enter the CubeNexus Decision Intelligence Suite, you get to it by going to cubenexus.ai. We have a pretty simple A/B option when you join. So the first is a data selection mode. This is important for users who want to explore specific data sets, and this is mostly what I'll be showing you today, as that application is very easy to basically limit the amount of data that we are investigating. But we also have this agent mode, and the agent mode is essentially a series of AI agents that this agent delegates to built on our AWS backend to allow you to filter by time and space different areas that you might have hooked data up to, but also, as you'll see, investigate public and open source data. So I'll show you both. So the data selection mode, if I click this, I'm going to get a data panel where I can either upload or select data. First, we have public data sets. We've already parsed and ingested quite a few of these. I'll show you quickly what a subset of these public data sets look like. You are able to mix and match private and public data sets. We have a multi-tenant architecture that prevents data from private data sets flowing into public, but not vice versa. So we can get the analytical benefits of having the public data inform the user data. Next is my data sets. So these are a lot of the data sets that we will be exploring today. We have some UI work and improvements, some features coming out to make this more user-friendly, searchable, and selectable. As you can imagine, if you are ingesting hundreds or thousands of data sets, this icon-based management is not very user-friendly, and that is some feedback we've gotten and we're working on improving. But for demo purposes, it's great because you can see different data sets, and I will show you exactly when I go through the specific scenarios. We have CubeNexus data sets, which are basically the way we feed data into public data sets. And then we have uploading data. So from an individual level, if you're an individual user analyst, geospatial analyst, you can just use CubeNexus as a standalone. It's $45 a month basically, and all of that is up in the account section of our user profile up here on the top right. But this allows you to upload data. Essentially, I'll just select a few data sets so you can see. I just selected 5 data sets from one of the scenarios that I'll be sharing with you. And there's then basically a wizard. Half of this is automatic, so these will fill in automatically. As you can see, the date column filled in automatically. And this is what allows us to parse the data into the cube-based framework. Basically integrating everything based on time and location in a volumetric way, making all that data instantly AI native and visualizable in 3D. So I will go back there, and I'm going to just come up here to the top right and click switch from data selection mode to agent mode. Now, this is a feature that we just recently launched about a week ago, where now I can actually query certain areas without having to select the data sets in particular. So I will ask a question such as, tell me about weather trends in the Southeast United States. And this agent will basically go through a series of filtering and essentially time and space filters to give me you can see here, several weather-related data sets, but I need to clarify, do you specifically want information about weather trends in Southeast United States? Most of the weather data I see is from New York, Texas, and Virginia. Would you like me to analyze weather data from the Virginia data set as it's in the Southeast, or would you like me to look at the Virginia or look at a different region? I'll say yes. Please tell me about the weather data in the Virginia region. So this basically, as we pump and push and upload more and more public and open source data into this, you'll be able to just query essentially all sensor data collected by the government, open source sensor data collected from public companies, private companies, and overlay that onto your own data sets. So wanted to show that first of all, because it's important to understand that it's not just the data that you upload, that you ingest through a data lake. It is also data that we are actively structuring and bringing to the user. All right, I will now go to our first scenario. This is taking a little bit of time to think. So the first scenario, this is actually a visualization of one of the public data sets, which is great. So the visualization you're seeing here is actually earthquakes from a USGS survey data set that we pulled. And I just wanted to pull that to show kind of what the public data sets look like. You could imagine overlaying a specific mining operations data on top of this, looking at time series trends for microseismic events with earthquake data from an open source. But let's get to energy. So I'm going to switch now to our first energy example. So I've chosen the data set selection mode on the website. So on the platform, this is a scenario of a grid operations event in New York. And so over here on the left-hand side, I have the LLM. Now, the models we use for LLMs are Llama and Claude models. You can use other models. We have quite a number that we have at our disposal working with AWS. We don't use ChatGPT at this moment, and we don't use Gemini, but we use quite a number of the other ones. Llama and Claude are the best performing, especially with Meta's new Llama release. So what I'll show you first is the data that we've actually selected. So I'm going to click on the bottom left corner of this screen, this little cube where it says select data sets. These are the data sets that I've selected in order to start my investigation and try to find meaningful insights and visualizations of the data in this New York grid operations region. So you can see some of the titles of these data sets. So grid sensor telemetry. We built a few LiDAR scan data sets over time. All of this is in a time period you can see of 2 weeks. So you can see September 1st to September 14th. The precision of the data is on here. This is based on the GPS location of the data itself. And the number of grains, this is basically, let's say there is 1,000 rows or 5,000 rows in a CSV sheet. We break that up into thousands and thousands more grains, which is our structured data so that we can actually do this complex investigation. I'll just read some of the other data sets that are on here just for your understanding. So we have maintenance tickets and work orders, 80 tickets logged over 2 weeks. We have LiDAR vegetation point clouds. So this is from an aerial LiDAR scan of vegetation over time. You can imagine how that would be important for grid operators. So vegetation gets in the way of a electrical line and causes a short. We have hourly observations from 2 New York rural weather stations. So we can assess impact of weather on top of, let's say, maintenance tickets or substation performance. We have truck roll logs, which are 120 vehicle trips over 2 weeks with the timestamps, crew, distance, fuel use costs, reason for them going out to do servicing on these substations. And then we've overlaid financial KPIs and financial data on top of that, which is linked through an intermediary ID to the location information. So obviously financial data doesn't have location information. Generally, you don't download your P&L or your cash flow statement or your general ledger and have the location data on that document. But when you parse out the let's say the asset operations costs for a specific location, generally there's an ID or a join code for that location that we can then attach to a latitude, longitude, elevation, and all of that. So that's what CubeNexus does for the user, is all of that time location synchronization. So now you probably want to see the queries and how we actually perform on a analytics basis. So I'll close the data visualizer here. All right, looks like it's all good. So the first thing I've asked is just for it to show me the data and tell me what data is in this data set. I'm going to zoom in just a little bit so you can see what this actually is representing. So what you're seeing again is not the data itself. You're seeing where all of the data sits spatially. And you can see the different levels of investigation, precision of the data over on the left-hand side. We can actually turn off these higher levels because I know from looking at my data report that most of this data is at either 2 kilometer, 200 or lower precision. So I just want to keep on maybe the 200 and the 20, but then all these smaller ones I can turn on and off. So you can see right in the middle of where the aerial LiDAR scan was. That's where all of this very high precision data is. So right here at the top of the visualizer, that's where all this LiDAR scan data is. And that's where you are seeing that high concentration of, if I turn off all of these other higher precision, you're seeing all this very precise, like 2 meter or yeah, there's even some 20 centimeter data in there that it's kind of hard to see without zooming in really close, but that's or 20 centimeter data, that's the LiDAR data. So this gives you an understanding spatially of where everything is. And I'll run through kind of some of the rest of these queries quickly, just so that we can get to the other two scenarios before we go to Q&A. But one of the questions that I asked, and I'll ask one live here in a second, but which feeders or substations had the highest combination of operations maintenance costs, so truck rolls, maintenance tickets, and repair spend over the past 2 weeks, and what were their main drivers? So all of that financial, location, and those O&M costs are in the data set selected. And so it's going to do a calculation, analyze which data sets it needs to look at, do a combined O&M calculation, which actually our LLMs can do math pretty well because we're essentially doing all quantitative Excel-based calculations. And after seeing this, you can see that it's actually selecting two feeder substation IDs with the highest O&M costs, which are FD001 and FD002. The main drivers are the high frequency and cost of maintenance tickets, and then it gives you I won't read through all this, but it's going to give you the breakdown of what are those costs, how much were they, and then I could ask the next question, if I wanted to reduce O&M costs for FD001, what would be your recommendation? So this type of analysis is essentially replacing like the hours of work that you would have to do, pulling together all these Excel files, doing join tables in Snowflake, running regressions, and then maybe getting something simple that you could put into ChatGPT and ask this question. We do it all right away, right? We do it all immediately, and we provide the reasoning and everything for it. If we click the show report button, we actually are completely transparent with how our LLM is working, how our data integration is happening, and we provide the transparency here. So we'll see how long it takes to think and answer this question. I don't see any more questions in the chat at the moment, but feel free to put any end and I'll move to the next scenario. All right, let's see what it says on to reduce O&M costs. Yeah, so it's going to tell me pretty specific stuff. Review and optimize scheduled maintenance schedules. Total scheduled maintenance for FD1 is $500. Investigate causes of unscheduled maintenance. Unscheduled maintenance was $3,000, which is significantly higher than scheduled maintenance cost, et cetera, et cetera. So for the sake of time, we'll move on to the next two scenarios. I spent the most time on the first one because I think it's important to understand the data interaction, all the LLM features, and how we select data. But I'll just go to the next data set so we can see a few more examples before we open it and I answer some questions. So this is a midstream example. So this is a bunch of pipeline data that we have put in Houston area. So you can see, I'll just zoom in and you'll actually be able to see some of the details of some of the pipeline information. Again, our system is completely three-dimensional, subsurface to space, so we could investigate subsurface underground information. We're still working on the visualization of that to a certain extent to get the subsurface visualization really good. So in future demos, we'll definitely go over that. I'll show you the data sets here. So we have dig permit data, some LiDAR data as well. We have quality line data. We have environmental monitoring, incidents, and then a bunch of financial data. So tariff, contract penalties by station, insurance claims by station. Then we have weather data, SCADA flow, which is sensors on the pipelines themselves. So I'll go through the LLM real quick. It's going to give me the kind of summary of all the data. And you can close, I'll just show you this way. You can close this and we can look at the LLM here. And then you just click on this visualize grains button again. Like there's a bug there once I close it down. This feature was just released this last week, but to be able to basically open and close the visualizer. All right, so like one question I asked was how much downtime, what cost was avoidable if maintenance work orders have been scheduled proactively around weather and pump energy alerts. and it's going to go through and say, like, this was only a week of data, so the avoidable downtime cost was 809, and it's going to tell the rationale for that. Happy to go back to these, but just for the sake of time, I'll go to the last example. So this is an offshore oil rig example. The data that we have selected is subcontractor support, vessel, like so boat movements to and from or around the rig, bunkering fuel prices, pig tracking to and from the pipelines coming to and from the rig, and then a bunch of financial data, for example, commodity prices, EFMS fuel per tank. So that's like fuel per tank, and there's also fuel per vessel data. So you can kind of start to analyze different costs associated with fuel spend. And one of the queries that I had just prepared previously was talking about vendor support craft efficiency. So this is the actual vessel supporting the rig. Which support craft hours don't correlate with pumping windows or safety needs, recommend time cuts, charters. This is trying to get a question of trying to get to like, how do I reduce overhead based on my subcontractor performance over this past week? And it has all of that data, right? So it has how many vessels were used, when, what are the rates of the people being paid, where did they go, were they using an efficient route? All of that type of information here at the fingertips of the analyst. So I'm over a couple minutes. I'm happy to go show more queries, explain more any of these scenarios, but we're trying to really demonstrate how it's truly data dependent on what data you pull in, right? And we can parse all of it synchronize it on time and location, and then basically give the analytical tool to do all this very efficiently quickly. So I will pause there. I'm going to click a little bit around here while we, let's see, I'm gonna send a survey to everyone in just a second. But what questions do you have? Feel free to put them in the chat, and I am happy to answer. All right, so I'll answer this live. So Marshall asked, what kind of integrations and benefits does CubeNexus bring to Esri, SLB, Schlumberger, and IHS data backends? Can you leverage these existing databases? So the most important thing is the time and location information. So the existing databases that most of these companies are using are very siloed and fragmented. That's one of the challenges that we're trying to solve as well. It's not just the analytical tool. Our parsing backend is essentially built to pull in data from various data lakes and front end upload, which is what is much easier to demo. And I should probably do a separate demo eventually on the data lake and backend ingestion, because that's much more relevant to enterprise users. But essentially, yes, the answer is yes, Marshall. The more integrations that we can build with existing data backends and basically push unstructured data from our customers into our parsing software to be able to get it into the standardized cube-based framework, the greater market penetration we'll be able to have. Because one of the big problems when we first started the company that we realized was 90+% of data that companies have collected historically and are currently collecting now is not being used very efficiently, or it's not being used at all. Snowflake and Databricks and other data warehousing database solutions have I mean, you can go Google it. There's articles out there on it. They've talked about it in their webinars, trying to get their customers to use their data more. So that's why we're really right now leveraging our relationship with AWS a lot to help build those backend integrations. We have had open conversations with Snowflake for the last month or so. We're working on building a connector with Snowflake tables. That's customer-driven request by one of our leads that wants to be able to basically ingest data through their Snowflake data warehouse. There is a potential Databricks solution at some point. We don't use Databricks right now, but we've kind of been going back and forth about that. Some of this data, Marshall, is just stored, in, on-prem, which is a bit, or, in physical storage, which is a lot bigger challenge. That's why the earlier go-to-market for us is to work with the intermediary, like data warehousing companies, the cloud providers, to be able to ingest data that's already there. All right. Thanks for that question, Marshall. Feel free to answer any more or ask any more. We have about 3 minutes left. One other thing I will show you. I'm just going to close this out. We're working a bit on making the entire interface more customizable, essentially, so that similar to what you would do in like another LLM that you use, you can kind of like build projects and customize all of the different investigations that you've done. So that's another feature that we have kind of in our backlog. Christina asked, let's hit this live, what software are you using for mapping? So I'll just go back to where I already have a map up. So this is a big open item for us, I would say, Christina. So right now we're just using open source cesium tiles for the Earth. All of the correlation or linkage between locations and the cubes and landmarks and all of that is either synchronized through the LLM's general knowledge, or explicitly we've basically linked most like well-known terrestrial data points to which cubes they belong in, so that whenever a query is asked, we can say, all right, we know that Halifax, Nova Scotia is in this area, so now we're going to spatially filter all the data that's in that area. The reason I say it's an open question for us is what we would really love to do and what we're working on is to basically build the entire Earth out of grains, so out of our data structure, and be able to just use or purchase satellite imagery on top of that and ingest the actual satellite imagery in grains as well. If you think about what the real promise we say we offer is all data is in a standardized data format. That includes the Earth. The Earth should either be in grains or it should be exactly precisely in 3D attached to the cubes, to the grain structure that we have. So it's something we're working on. It is very difficult. It has been difficult to do just because of the kind of monopoly that Google and Cesium and other providers have on satellite imagery and on 3D tiles and 2D tiles. But we will get there, because once we do that, to the point of Marshall with Esri, we can basically provide a analytical framework for anything that on. Oh, sorry, everyone. Looks like I just got kicked out for a second. That is the end of the time, so I don't know if that happened accidentally or on purpose. But I will stay on for just 2 more minutes if anyone has any more questions. And if not, then we can wrap it up. But I really appreciate everyone being here today. Please reach out if you have any questions. I will just share the slide deck again so you have my contact information. So feel free to reach out. I don't see any more questions, so we'll wrap it up today. Thanks so much, everyone, for coming. I really appreciate it. It's really good to see everyone here. Thanks so much for everyone who has supported us, investors on the call, our advisors, and then all of you who are just interested and potential customers. So here's my information. Check out the platform at CubeNexus.ai. We allow you to use at least 10 queries for free. You can test out the visualization there. And if you want to pay for it, if you have a use case, we would love to have you as a customer. And then if not, feel free to share with anyone who you think might be interested. So we'll wrap that up for now. Thank you so much. And everyone have a good day.